Teachers, students, and all fans of Dr. Sami YouTube channel. Welcome to another of my revision here. And for this time, I'm revising KCSE 2022 Mathematics Paper 1. For this one, I'll just do section 1. Then the next video, we go through section 2. So my student, more especially, welcome. We first of all go through the question paper. There is the cover page, the instructions to the students, the space where the student is to write the names, the index number, sign, and the date. Remember, this is an exam that was done last year, that is the year 2022, sometimes December 2022. There is the grid. As usual, these are paper 1. So 16 compulsory questions. 8 questions in section 2 where the student is to attempt 5. There goes the question 1. Okay. Question 2, my student, you can see it there. You go through it. Question 3 and 4. Yes. Question 5. Question 6 there, my student, you can see it. Question 7. Question 8 and 9. Yeah. I'm just giving you a chance to go through the paper first. Question number 10, question number 11, you can see. Number 12 and number 13 is there. Question number 14. Question number 15, question on statistics there. Question number 16. Remember, that's the end of section 1, and that's where I'll stop for now. But for the sake of your revision, you can go through the whole paper. That's question number 17. The first part. Question number 17 continues. Question number 18, my student, you can see there. Question number 19. Question 20 is there. Question 21. Question 21 continues. Question 22. Then 23, part 1. Then 23, second part. Question number 24. And question number 24, part B there. Well, that is the end of the paper. So my student, kindly stop the video. Stop the video, go through the question yourself, then you come here and we do the paper together. Thank you. Okay, my student, having gone through the question paper, now we can go through the marking scheme together. And this question 1, the student was expected to solve for n, a very, very simple question here. So what the student is expected to do some cross multiplication here, because you're given 6n over n minus 1 equals to 25 over n. So just a simple cross multiplication. And remember to put the n minus 1 in bracket. So just taking you through what the student was to do. Having cross multiplied here, I'll get 6n squared equals to 25n minus 25. Then a matter of rearranging the terms to obtain 6n squared minus 25n plus 25 equals to 0. A quadratic equation that gets earns the student the first method mark. So what is expected of the student here? Having gotten the equation, my student, it's a matter of factorization. And the best method here is factorization. Yes, you go ahead to multiply 6 by 25 to obtain 150 positive, and the second term is negative 25. So my student, what is that? We are looking for two integers such that the product is 150 and the sum is negative 25. Yes. Then if I consider that the product is positive, meaning either the two integers are both negative or they are both positive for this case. And therefore, if I consider the sum, negative 25, both of these integers will be negative. So negative 15 and negative 10. So what do I do with the two integers? I express the second term. Yes, with the two integers. Negative 25n is the same as negative 15 minus 10n. That is both with n. So having done that, now I can do factorizing. or factorization. The first two terms, 3n is a common factor. N minus 5 is what remains in bracket. The other two terms, 5 is a common factor, yes. And n minus 5 again remains in bracket. Remember, if I factor out a negative, what was a positive will be negative. Okay, if this was a negative, then it will be a positive by factoring out a negative. I know my student, you know that, equals to 0. Then I can factor out negative 2n minus 5, yes, and then I get 3n minus 5 as one factor and the other factor. If a student was able to factorize that, then the student was able to get the second method mark. Then I go ahead to solve. If the product of two numbers is equal to 0, then one of the number is equal to 0, my student, that is. So either 3n minus 5 equals to 0, then I solve for n, and I get the answer, 5 over 3, or 1 2/3. Then 2n minus 5 equals to 0. So that is it. Then I solve. Getting the two answers, a mark. The first question done. Okay, we go to question number 2. A family uses 2/5 of the income on school fees. 3/4 of the remaining was used on family upkeep. The rest was invested. The amount invested was 13,500. So calculate the amount of money the family used on school fees. We go ahead to see how to work out this. Let the total income be X. Okay, though it's not a must, you can decide not to represent it. But we know 2/5, 2/5 of the salary was used on school fees. So 2/5 of X. Okay, good. Then we go ahead to work out the 3/4 of the remaining. If 2/5 was used on school fees, then it means 3/5. The remaining portion is what was, of course, remaining. So 3/4 of the remaining. You can see that 9/20x of the original x. You can decide to use x or just leave it as a fraction. And that's where the student earns the first bonus mark. Then what was invested? My student, it is 1/4 of the remaining. Okay, 1/4 of what exactly remained. Because remember, 3/4 was used on family upkeep. That means the 1/4 was what was used in as an investment. If I do that again, I get 3/20x, and that is what is represented, or that is what is equivalent to 13,500. You can see 3/20x is equivalent to 13,500. Then I go ahead to work it out. I get the value of x by multiplying by 20/3 on both sides. By doing that, just that expression, a student gets another method mark. But that figure gives us 90,000. Then what was used on school fees? Now that we know the value of x, the total income, monthly income for this family is 90,000. So 2/5 of x. I do multiply that and I get a method 1. Then I get the answer, that 6,000. That is how the student was to do that question. Whichever other approach the student will use, provided the working is correct. That is it. Question 2, well done. Going ahead with question number 3, the student was given 5 raised to power 2x minus 1 minus 25 raised to power x equals to 500. So the student was expected to solve for x. So there is the working. The first part, I can split it because of this negative. I can have it 5x raised to power 2x multiplied by 5 to the power negative 1. Remember, what I've just done is to apply the law of indices. Then minus, this is 25. It is equivalent to 5 raised to the power 2. Already there was an x, so 2x equals 500. You can decide to write down your 500 in this format, of which it's okay. Yeah, it's fine. Then you factor out 5 raised to the power 2x. 5 raised to the power 2x. Factor it out. Remember, 5 raised to the power negative 1 is a fifth. A fifth minus 1, because what remains here is 1. My student, you can assume that this is m and this is m. So if you factor out m, you'll have their fifth and minus 1 here. That's all we've done there. Equals to 500. Then you have a fifth minus 1. It is negative 4 over 5. Then 5 raised power 2x equals 500. Having done that, my student, then I have 500 here. Yes, this is negative 225, yes, which can also be written as this. And how did I get this? It was the negative 4 over 5, yeah, the reciprocal of it multiplied on both sides. If I do negative 500 multiplied by 5 over 4, I'll get negative 200 and negative 625. Yes, my student, you can see that. Actually, this question had its own maybe setting issue, because the farthest the student could go is what we have here. And for the marking purposes, this served as the answer, because with this, because of the negative, you cannot go beyond there. However, I've tried to do some correction of what was expected of this question. But for this one, as far as KCSE 2022 is concerned, paper 1, that's the farthest the student could have gone. But look at this. This question ought to have been like this: 25 raised power x minus 5 raised power 2x minus 1 equals to 500. So that is exactly how maybe the question was to look like. And if this was the case, then that is the working. That's the working. The 25 raised power x, you write it as 5 raised power 2x minus just the other one as it was, equals to 500. Having written that, now we can write as we did before. This is 5 raised power 2x into 5 raised power negative 1. Okay? Having done that, then I can factor out the whole of this term. We've said you can represent this with an m and this one with an m. Then you factor it out. You'll have 1 remaining here minus a fifth. If that is the case, you can see now that is 4 over 5 without the negative. 5 then the 5 2x there equals to 500, or the way I've done. If you continue, my student, up to this point, you have two indices whereby, or yeah, the two indices whereby the base is the same. Then you equate the powers. 2n equals to 4. You solve, you get 2. So maybe that's how this question ought to have been. But we followed both ways. We are doing some revisions here and there. We go ahead to number 4. You're given that there are two athletes here. You have Kipkoech and Tanui. Both are intending to run 5,000 meters. Then they were together at the starting line. Kipkoech and Tanui can take 72 seconds and 80 seconds to go through 400 meters. Then the two athletes were together again at a starting point after some time. So you determine the number of laps that Tanui had to run to complete the race after they were together. So my student, that's how you go about this one. First of all, get the LCM of 72 and 80. Whichever method you use, well and good. The first bonus marks was for the LCM, 720. Now, look at this one. 720 is the LCM. If I divide by 80, I multiply by 400. Why am I dividing by 80? The seconds that Tanui takes to go through one lap, 400 meters. So how many laps will this person make? 700 divided by 800 times 400. So the total distance that Tanui will run before they are together again at the starting point is 3,600. Sorry for that. 3,600 meters. Now, the total race was 5,000. So Tanui is yet to do 5,000 minus that 600 meters. That is the distance this athlete Tanui is having to complete the race. So if I divide by 400, I will get the number of laps that Tanui is yet to make. That is alternative 1, and the answer is 3.5 laps. Okay, if I can go ahead to get another alternative, I have the LCM, the first mark. Then the time taken for Tanui to run 5,000 meters. If at all he's alone, 5,000 meters, it will be 5,000 meters divided by 400 times 80. Why 80? Tanui is taking 80 seconds to go through one lap. So the total time taken for Tanui, it will be 1,000 seconds. Okay? Tanui will have to take 1,000 seconds to run 5,000 meters. Now, the 720 represent the time taken for these athletes to go around the field before they are together again at the starting point. So if I subtract the time they will be together again at the starting point, then I'll have 280. What does that mean? It means this is the time remaining, or this is the time remaining for Tanui to run. So 280 divided by 80, you get that time is enough for Tanui to go through the field 3.5 laps or times. That is all. Okay, we move on with question number 5. Good. You're given an expression here, 18ax minus into bracket 3a minus 4x, cross the bracket there, open a bracket, 3a plus 4x over 3a minus 8x. So the student wants to simplify. This is just a simple algebraic simplification here. Good. That is how we go about this. And look at this part from here, my student. This is the point where the student was to start by expanding 3a minus 4x into 3a plus 4x. That is the factor. Those are the factors for what we call the difference of two squares. So all you need to do is to square 3a, I get it here, minus 4x squared. Again, there it is. So actually what we have to do is to expand. From here to here, we are expanding. Okay, you can use quadratic identities. You expand. Then, having done that, we are good now to simplify. The numerator, you can see now, it can reduce. If I open this bracket here, I'll get 18ax minus 9a squared plus 16x squared. Or just the other way around. The 16x squared plus 18ax minus 9a squared. If I consider that 16 is my coefficient, the coefficient of x squared, 18a is the coefficient of x, and then the negative 9a squared is the constant. So this is again a quadratic expression. You need to simplify. Products of two numbers equals to 16 times negative 9. That is negative 144. The sum is positive 18. Remember, the first marking was this expression here. Okay, the two integers, positive 24 and negative 6. Okay, if the product is negative, one of the number is negative, the other one is positive. Okay, what dictates the two integers? It is the sum. The sum is positive. That means the bigger number here is positive. Simply like that. If I go ahead and do the factorization, the ordinary factorization, as you can see, my student here, identify what is common between these two terms, factor it out. Yes, then identify what is common here, factor it out. What is in bracket again, factor it out. 2x plus 3a. Yes, and then 8x minus 3a there. These are the two terms. That is where the student scores the other 1 mark. The denominator, as simple as it was given, here it is. You cannot factor out in that far, but when you consider what is in the denominator, the numerator up here, we can work on this denominator by factoring out negative 1. Why are we factoring out negative 1? Because in the numerator I have 8x minus 3a. So I want something that looks like that. So if I factor out negative 1 here, the negative 8x will be positive. Whichever was positive 3a will be negative because I factored out a negative. And that's what I've done here. Then I have two terms that are similar. This one I cancel by itself 1, by itself here 1. So what exactly remains? 2x plus 3a divided by negative 1. And that makes now the 2x to be negative, and then the 3a also to be negative. And that's how I end up with this answer. My student here, negative 2x minus 3a. Well, my student, try as much as possible to follow. Just follow that. Follow what I've tried to do there. That is question number 5. Question number 6. The student was given a quadrilateral ABCD. Okay, you can see that. AD and CD are equal. AD and CD, they are very equal. They are 6 centimeters. AB, yes, AB is 12 and it's equal to BC, which is 12 centimeters. The angle ADC, it's 300. Well, the question was that the student to calculate 2 decimal places the area of this figure. So all the student was expected to do, you join A and C with a straight line. Yes. Remember, if this is a straight line and this is 6 and this is 6, automatically it means this one will be 6. That can also be confirmed by this triangle. If this angle is 60, by subtracting 360 from 300, you're actually subtracting 300 from 360, you get this 60. It means even this angle is 60 and this is 60, because these two angles are equal. By that, this line AC is 60. If I drop a perpendicular from B all the way to a point P here, it means this line here, from here to a point P around here, is 3, and this is 3. Having done that, I'm good to do the calculation. Let's do the working. We want to get the height PB from P to B. We're using Pythagoras theorem. PB squared plus, that is the height, plus 3 squared equals to 12 squared, the hypotenuse. You can see the hypotenuse there, my student. By doing that, finally I end up with the PB. I can leave it in third form. That is the square root of 135. Yes, okay, just leave it as that for one bonus mark. The area of triangle ABC, ABC, the whole of it, the unshaded, or rather the external part here and the figure, it will be a half times base. The base is 6, yes, multiplied by the height, the new height. And having done that, my student, I get 34, that is 34.86. Good. Then I proceed now to do the area of the external triangle here. A half times 6 times 6 again, yes, the two sides, a sine of 60, sine of 60. And the sine of 60 means I'm using the sine formula, and I get 15.59 centimeters squared. So I have the area of the external triangle here and the entire triangle, including the figure. Then I only need to subtract, my student, the area of ABC. Yes, I subtract the area of ADC. Just what I've done, and I have it here, and a 1 mark there for the answer. That is question. Okay, number 7. Number 7, a watch loses 8 seconds every 1 hour. It was set to read correct at 11 hour on Sunday. Determine the time in 12-hour clock system. The watch will show the following Thursday when the correct time is 5:00 hours. Well, these are questions similar to a question I had posted here. And this is how the student was to do the question. Now, on Sunday, we are given that this clock was set correctly on Sunday 11. So the remaining hours for Sunday was 24 minus 11, 13 hours. So it had 13 more hours for Sunday. From Monday, Tuesday, and Wednesday, 3 days by student, multiplied by 24 hours in a day, 72 hours. Then we have the other day, Thursday. We are considering this to be Thursday of that very same week. That is the Thursday of the week, the very same week. Not that followed, because I remember the other question I had maybe a different view of the same. But for this one, we're considering if today is a Sunday, the following Thursday will be the coming Thursday. Yes. With that, my student, Thursday, 5 hours from midnight to 5 a.m. That is 5 hours. Total number of hours between the time the clock was set correctly to the new time that we are considering here, it is 90 hours. That is the first mark, my student. Now, if within 1 hour the clock loses 8 seconds, it means within 90 hours it will lose 90 multiplied by 8 divided by 60, just to make the seconds or to convert the seconds to minutes. So this clock for the 90 hours, it will lose 12 minutes. Okay, the correct timing is 0500 hours. So the clock will have lost 12 minutes. You subtract 12 minutes, you get 0448 hours, which can be converted to the 12-hour clock system to be 4:48 a.m. very early in the morning. That is it. That's question 7. Follow just what I've done, my student. Moving on to question number 8. You're given that Aroli left town A for town B and maintained an average speed of 50 kilometers per hour. A car left the same town 42 minutes later, headed for B. The speed for the car was 80 kilometers per hour. Then at the time the car arrived at B, the lorry had 25 kilometers to cover. Then the question is, determine the distance from A to B. This is a form 2 question. Yes, a linear motion. And the question has several ways of doing. So my student, I will take you through the 3 methods, the 3 approach here. Okay, look at the first one. Let's assume the distance from A to B is x kilometers. From A to B, as I have illustrated, x kilometers. Now, let's look at the distance covered by this lorry before the car started. That is 42 minutes before. The distance is speed multiplied by time. This time will be in hours. If I multiply that, I get that 5 kilometers. And what is this? This is the distance the lorry had covered before the car started. So we can, in other way, say that the lorry was at point P when the car was starting. Now, how do I argue about this? Remember already the student has the first bonus mark by doing the kilometers here, that 5. But how do we argue out? Look at this. The car traveled from A to B and covered a distance of x kilometers at a speed of 80 kilometers per hour. So if I can divide distance divided by speed, I'll get time. The time taken by the car to move from A to B. The very same time, the lorry moved from point P to another point here. Yes, I can see this point, 25 kilometers from B. Now, what can we say about this distance? It is x, the whole distance, subtract 35 added to 25. So subtract 60. So the lorry moved from P to this point here. That is the distance, x minus 60, at a speed of 50 kilometers per hour. That same time, it is the same time the car moved from A to B. I hope, my student, you can be able to argue out that well. And that's how we come up with this illustration here, or this equation. Having done that, it's a matter of solving the equation, my student. You cross multiply here. If I can cross multiply, this is 50x, 80x minus 4800. You can see, like I have done the solution here. I have solved this one. With that, if you go ahead, 30x is 4800, you get 160 kilometers. So the distance from A to B is 160 kilometers. That is method 1. Okay, let's move on and try to see another an alternative method. Again, we let the distance from A to B be x kilometers. You're given that this car, when it arrived at B, the lorry was 25 kilometers away. as we did with the first alternative, we can do A to P, the distance the road had covered before the car started, just like we did the 35 kilometers. Now, we approach this question using what is called the relative speed. What is the relative speed? The difference, like in this case, the two bodies are moving towards the same direction. So the faster vehicle is subtracting or is going beyond, it's covering us, it's moving at a speed faster, at a relative speed faster than the slower. So 80 minus 50, you get 30 kilometers per hour for the first bonus mark. Having done that, that is the relative speed, my student. When the bodies are moving towards the same direction, you subtract the speeds. That is the slower speed subtract from the faster speed. If the bodies are moving towards each other, my student, this one we will add their speed. That one we need to be very conversant with. Now, we talk about the distance of separation. When the car was at rest, when the car had not started, the lorry was 35 kilometers away. When the car stopped at B, the lorry was 25 kilometers away. So what is the distance of separation? Okay, my student, it is 25 plus 35, 60. Having gotten the distance and we have the speed, now we can work out the time. What is this time? The time, okay, the time that separates these two bodies, that is 60 divided by 30. You get 2 hours. 2 hours is the time the car took from here to where it stopped. So 2 multiplied by the speed for the car, 80 kilometers per hour, you get 160 kilometers. That is an alternative method of doing it using the relative speed. Okay, we move on, my student. I want to take you through another alternative 3 for this question. Again, let the distance from A to B be x, like we did before. We are given that when the car arrived at B, P is the point 25 kilometers away where the lorry was. And with that, the distance from A to where the lorry was when the car arrived here, it is x minus 25. So the car, as we argued with the method 1, moved from A to B x kilometers at 80 kilometers per hour. That is now the time, distance over speed. This time is equal to the time that the lorry moved from here to this point P, x minus 25 over 50, less the time it had traveled before the car started. That is 42 over 60. So when I have this illustration, a bonus mark, remember I can reduce it to this format, okay? Having done that, my student, I just need to solve this. I cross multiply, yes, 160x minus 9600 equals to 100x. I go through that. After multiplying the like terms together, I go ahead to solve that, and x will be 160. Remember, my student, those are 3 different ways of doing question number 8. Allow me go to question number 9. This is a question on bearing. And before we do bearing, I can take you through this Form 1 concept, the bearing. And we have 2 types of bearing, compass bearing and true bearing. And I start illustrating for you here what we call the true bearing. The true bearing, we always measure the bearing from the true north, okay? And we go clockwise. From the true north, we go clockwise. Consider like this one. This is point A. From the true north, that is an acute angle. For instance, maybe it is 80 degrees. So the way we give this true bearing, we do 0, 80 degrees. You can see like the way I've written, 3 digits. Okay, if I consider point B, that is maybe 156 from the true north, so you can see that angle 156 degrees. With 230, the other one, okay, point C, you can see 348. It is from the true north all the way somewhere there. So that is the point C. That is true bearing. From the true north, we go clockwise. Now, consider this one. This is a compass bearing. The compass bearing is given from the principal line north-south. You can see the principal line north-south. You consider, is the point to the east or is it to the west? Just that. Now let's take an example of point X here. That is 28 degrees towards east. You can see that point is between north and east. So how do you write that? It is north, yes, 28 degrees on the eastern side. You can see that. That is the compass bearing of point X. Consider point Z, that is to the south. You can consider this one. From this point is to the south, and it is 72 degrees to the east. You can see that. And remember, you can now try to convert even the compass bearing to true bearing. If I'm talking about true bearing, it will be this angle here, 180 minus 72. Maybe it will be 180 degrees. So for the true bearing, if I consider point Y, this one, it is 48 degrees on the southern part towards west. So it is 48 degrees. You consider this one. Okay, Y will be south. I think this should be south, 48 degrees west. Yes, you can change that one. This is south, 48 degrees west. If you talk about point W, it is north. It is to the north, 56 degrees, yes, to the west. And why am I taking you through that? Because for question number 9, the student was given the compass bearing, and you're given that there is a port L, 120 kilometers on the bearing of south, 30 degrees west from a port K. A ship left port K at 10 hours and sailed towards at a speed of 40 kilometers. That is 40 kilometers along the bearing of south, 60 degrees east. Using the scale drawing, determine the bearing of the ship from the port L at 14 hours. Remember, it started from 10 hours. Okay, my student, we can look at a sketch for that. Yes, we can go ahead and look at the sketch before maybe the drawing. If you look at this sketch, we are talking about the port K. Yes, there is a port K, and then there is another port L, that is 120 kilometers. You can see 120 kilometers. The bearing is south. From here it is to the south on the eastern side, 30 degrees on the not on the eastern but on the western. This is the west. Okay, so you can see the position of L. Then you're given that there is a ship that is sailing at 40 kilometers per hour along the bearing of south, yes, 60 degrees on the eastern side. You can see that. So if you are measuring, you can measure an angle of 60 here, an angle of 30, and then mark proportional. So this is basically the sketch, but you can as well go ahead through this working. The time that the ship took to sail from the point K to where it was at 14 hours, it is given there. 14 hours subtract 10 hours, you get 4 hours. The distance covered, it is 4 because it has traveled for 4 hours, multiplied by 40, 160 kilometers. So it was 160 kilometers away from K. Now the scale that it's most appropriate is 1 kilometer to represent 40 km, and that means the 160 km will be 4 centimeters because you just need to divide by 40. This is 4 centimeters. Then you have the 120 divided by 40, you get 3 centimeters. So even as you go ahead to draw, you're having the very appropriate scale there. With that, the student has a bonus 1 mark. We can move on now to just look at how the student was to do the construction. Maybe what you can do, my student, is to construct it yourself. From here, measure an angle of 30. Yes, an angle of 30 from the principal line north-south on the western side. Yes, mark 3 centimeters from K. Mark a point there. That is the angle 30. Again, measure an angle of 60 here. Yep. Measure 4 centimeters. Mark that point. Having done that, you need to construct a line that is parallel to this one at this very same point. Having done that, yes, you can measure now this angle. You can measure an angle from the north. Remember, the angle here is from the north, and that is the bearing of the ship from port L. That is, if you have to give it in compass bearing, it will be north 83 degrees east, maybe plus or minus 1. Yes, plus or minus 1 for the allowance there. And in case you want to give it in true bearing, 083. Question number 10. You're given that the image of a point P, that's negative 2, 5, and our translation is given. There it is, 2, 2. And the Q, yes, the image of Q now is given. Yes, 9, negative 5, and under the same translation. The question is, you determine the coordinates of Q. Yes, in one of the previous examples I did for you, my student, I told you about OT. OT. Object, you add the translation factor, you get the image. OT. If you are a Kenyan, I know you must be knowing of one OT somewhere. Now, how do I go about that? I'm given the point, I write it in column form. I add to a translating factor AB. That is my translating factor. I get the object, and by doing that I can get the coordinates of AB, or rather the translating factor AB. And by doing that, remember, it will be, I subtract this same vector on this side, so it will be 2 minus minus 2, I get 4. Then I have 2 minus 5, I get negative 3. Okay, then I go ahead. This is the translating factor for negative 3 for the first bonus mark. Now I am looking for another point Q whose image is given. Okay, so here is the object, I add the translating factor, I get the image. Having done that, again I need to subtract this vector on this side. It will be okay, yeah, this, the xy will remain. I subtract the translating factor on this side, so it will be 9 minus 4, I get 5. Negative 5 minus minus 3, I get minus 2. Remember, that will be negative 5 plus 3 to be negative 2, and that tells you the coordinates of point Q is 5, negative 3 for the answer there. This question is very common, my student, and it's easy to handle. It's easy to handle. That is number. Okay, my student, question number 11. This is a question on commercial mathematics, especially the exchange rate. And as the question reads, there is a Kenyan bank, and it is selling the United Arab Emirates dirham, or just their currency. That's their currency. And this is the exchange rate for the 2 days given, the 1st of August, the 16th of August. You can see how the bank is buying the currency and selling the currency, that the UAE dirham. Now, there is a Kenyan tourist who traveled to United Arab Emirates on 1st of August. Then he had this amount of money, 130,050 shillings, that he converted to the dirham. Then during her stay, actually is a lady, during her stay he spent the 3520 dirham. Then she returned back to Kenya on the other date, 16th of August. On her return, she did a conversion of the shillings, or of the currency back to Kenyan shillings. Then the question is, calculate the amount of money in Kenyan shillings that this lady received. Well, something you should understand about the bank and the bureaus. They trade with the foreign currency. The selling and buying is not Kenyan shillings. They are buying and selling the foreign currency. So with this case, when you're talking about the Kenyan tourist traveling to United Arab Emirates and converting this Kenyan shilling, when she goes to the bank, the customer is having the Kenyan shillings, the bank is having the what we call the foreign currency. So it is the bank will be selling. In short, the bank will be selling. So as the conversion goes, at the first one we do 30,050, 130,050 divided by 28. We're talking about the bank is selling. Yes, 2890. The bank is selling because the customer is not with the foreign currency. So we are going to use 28.9 to convert. Get that and get it well, my student. I've said well, the bank and the bureaus always trade with the foreign currency. That's what they sell. Okay, so if the customer goes with Kenyan shillings, so the bank will be selling, yes, the foreign currency. And by dividing that, 1 mark there, and this lady received 4,500 dirhams for the exchange of her money. Then when she stayed in the Dubai, the lady spent that 520. You can see the subtraction there. This is the balance that she returned home with. Okay, moving on. The lady went to the same bank and did some conversion. Now she's coming to the bank with the foreign currency. What will the bank do, my student? The bank will be buying. So that's why we use the 28 shillings here. So we'll be doing 28 multiplied by that balance. You get the total money received there. My student, that is question number 11. Question number 11. We move on to question number 12. You're given that an electric post is erected vertically 20 meters from a point on the same level ground. The angle of elevation to the top of that post is 30 degrees from that point P, that is. Given that there's a point S that is midpoint of the post, then the student was to calculate to 1 decimal place the angle of elevation to the top of the angle of elevation of S from point P, not to the top but to the point S. Now, the best thing to do, my student, is to do an illustration. You need to draw this illustration, my student, and that is it. I've done an illustration for you. There is a point O, maybe the bottom point of the post, and a point P somewhere here, 20 meters away. That has been given in the question. There is a point S, the midpoint of the post, yes, and of course the top of the post. The angle of elevation from point P to S is 30, as you can see, the angle 30 here. And then the question is that we get the angle of elevation from point P to S. Yes, the way to do it, let this half be HH. That means this is H and this is H, two small H there. And then I go ahead to work them out. Look at what I've done. I'm basically applying trigonometry. The tangent, remember SOHCAHTOA, the tangent is opposite over adjacent. If this is my angle, the side to this or far end, that's the opposite. This is the adjacent. We are not interested with the hypotenuse, so we are not going to use cosine. We are not going to use the sine. Okay, my student, I hope you're getting that. So I'm using the tangent, and I'm talking about the tangent of 30. It is the height, the 2h. Okay, the 2h, then divide by 20. Why 20? It is my adjacent. So then how do I get h? Remember, I can do cross multiplication. 2h is 20 tan 30. Then I divide by 2. And by doing that, I get this 5.7754 meters. By illustrating the first one, I get the first mark. Now, I have the distance from S to O. That is it. I need to work out this angle. The tangent of an angle that I do not know is 5.774 divided by 20. And what exactly am I doing? Again, the same. Opposite over adjacent. By doing that, I get a ratio. Then I go ahead to work out the tan inverse of that, and I get the angle there. As simple as that. My student, follow what I've done. It is as simple as that. Maybe to me it's simple. To you, you need to practice and make it perfect. Good. We move on to question number 13. Question number 13 is all about matrices. Yes, matrices. And you're given a matrix A with a known here U, a matrix B here with again another unknown U here, negative U, and you're further given that there is a matrix A, BA. It is a B multiplied by A, and you're given there it is with again two unknown. The question is that the student determine the three unknown. Yes, the U, the V, and the W. Good. And look at this point, my student. It is B multiplied by A, not the other way around. Remember, we say matrices are not commutative with respect to multiplication. If you rearrange, if you talk about AB, maybe it will not be the same matrix. But that's not the issue. We go ahead to see what exactly is expected. The way we multiply matrices, like I have the row here, I multiply with the column. 7 multiplied by 2, that's 14. Negative 3 multiplied by 2u here, that is negative 6u, and it equals to 2 here. Why 2? The 2 is the element in the first row, first column. So I get it by multiplying the first row and the first column. With that, I'm good to form another equation. 7 multiplied by 6, that is 42. Negative 3 times 5, that is negative 15, equals to V. Why V? If I consider element V here, it's the element in the first row, second column. So I will multiply first row and second column. That is it. Remember, I can still have negative u times 2. I get 2u plus 10u equals to 16. That still can also give me. But remember that will have u, and I already have one equation with u. The other one will be I multiply u times negative u times 6. I get negative 6. Then plus 25. 5 times 5 equals to w, the element in the second row, second column. So second row, second column. So with the 3 equations, I'm good to solve. Equation 1 can help me solve A, for u, that is. With that, will be 6u equals to 12. 14 minus 2. Yes, that one, it will be 12 equals to 6u. And then I divide by 6 both sides, I have 2. Then I go to the next one. V will be 42 minus 15, 27. The other one, I already have obtained u. So u will be negative 12 plus 25. That is 25 minus 12. That is 13. And basically, this is my student. That is how you are to solve number 13. Number 13. Good. We are good to move to question number 14. A question on similarity. 2 similar containers, capacities are given 54 and 250. The difference in the heights of the 2 container, 4 centimeters. So calculate the height of the larger container. Yes, my student, this is on similarity. Good. That's how you go about it. Remember, you're given the capacity. Capacity means volume. So this is volume ratio, or volume, what you call volume scale factor. 54 is to 250. Remember, these two figures here, you can simplify. They have a common factor. So whether you write it like this, all 27 is to 125, all 27 over 125, all 125 over 27. Well and good. So that is volume scale factor. For you to obtain the linear scale factor, the cube root of the volume scale factor. And by doing that, my student get 1 bonus mark. And that is 3 over 5. Yes, that is 3 over 5. Already we have the linear scale factor, the ratio of any 2 corresponding sides. Now, we let h to be the height of the larger container. And now we're going to compare this one. 3 over 5, that is the smaller height or ratio over the bigger, it will be the same. You're given that the difference between the two maybe heights, it's 4. That means if the larger height is h, the lower or the smaller height is h minus 4. Having formed that equation, my student, mark. Then you go ahead to cross multiply here. Yes, this is 3h, this is 5h minus 20. Remember, this should be in bracket at all time, my student. That one is that. With that, you go ahead and solve. H will be 10 centimeters. As simple as that, my student. Remember, this is a national exam question, so it's a question that you can easily handle, and 3 marks is just some good marks for you, student. We move on with question number 15, a question on statistics. You're given that there are 2 classes, class Y and class X. The number of students per class as it is given, the mean mark of the class, maybe in a given exam. Then you're supposed to calculate to 2 decimal places the mean mark of the classes, the 2 classes combined. Simple and direct, my student. This one is simple and direct. We are talking about the mean of the 2 classes. Work out the total mark for one class, 42 times 65, 43, yes, times 65. You can see that total mark. Then the total mark for the other, yes, 45 times 62. Then the total divided by the total number of students in the 2 classes. As simple as that, my student. For 2 marks, you can see how I have done that. Remember, it is to 2 decimal places there. We're going to move on to the very last question that I'm doing for this paper. With section 2, I'll do maybe later. Look at this. You're given that this is the base of a pyramid. A, B, C, D, E, F. It is a regular hexagon. The sides are 2.5 centimeter. V is a vertex that is above the center of the base, of course. The length of the slant height or the edge is 4 centimeters. You draw a well-labeled net. Net is to open. You open that pyramid. That is the sketch of the pyramid as it looked. Anytime they use this word right pyramid, it means the V is vertically above O. Okay, and of course you can see the base there, and all sides are equal. 4 centimeters there. So how do you go about that? Direct. Draw the sketch. So how do I obtain this angle? Yes, remember this is the interior angle of a hexagon. Yes, maybe I've not included that formula because maybe it will not earn you the mark, but you need to know how to get this. How do you go about that? Usually 2n minus 4 into bracket 90. That is the sum. So with our n being 6, so it is 12 minus 4. 4, that is 8. 8 times 90, 720. 720 divided by 6, 120. Well, for that one, my student, I've just said it. Try to get it. So take your pair of compass, draw, and of course not a compass, but your ruler. Just do 2.5 centimeter, measure an angle of 120. Yes, draw a line 2.5 all the way to the other end. And of course, take a pair of compass here, mark 4 centimeter, from here 4 centimeter, all round, my student. If you are able to construct the hexagon, 1 bonus mark. If you are able to see all these triangles, another B1 mark. Then the complete figure there with all points labeled, another mark. Good, my student. That is the end of the part that I've covered for today. Thank you so much for watching, and kindly do not forget to come back as we look or rather we go through section 2 of this same paper. Otherwise, for the student preparing for KCSE 2023, I wish you all the best. Thank you so much, and keep coming for more and more. This is Dr. Sirme, and I love you so much, my student. Thank you.